Hi, Object Coder. Just a real quickie navigation style here on Big O. So we have a chapter here on Big O, and there's a lot more references there as usual. Just want to highlight a couple things. So when you're looking at this, what we really want to talk about with Big O is algorithm effort. How much effort does that algorithm expend? How hard does it have to work? So we're using the word effort. Key in on that. We're familiar with a linked list. We know that, let's say, getting the first data there, or the head of the list, we know that that's just one or two operations, right, to get that. Whether the size of this linked list is 2 as shown, or if it, or I should say 4 as shown, or if it is a trillion, same thing. We just go get that right there, getting the first element, right? We would return this BP data. So that the effort expended by that algorithm, as the size grows, there's no change in the effort. There's no increase in the effort. That effort is constant. We call that a constant effort. All right. No effort change. So not affected. In a case like this, a search, we know from our work that a linear search is going to have to scan the entire list if we're thinking worst case. And even half the list if we're thinking some sort of average. But either way, we know that the effort is affected by the structure growth. So I just want to key in on that word effort as you're looking through this. What else can we kind of touch upon here? Then just look at the notations, and it's the same kind of thing you'll see there. Question and answer format. Practical tips is good. This one is actually, all these are interesting, multiply tips, things like that, add tips. This is interesting too. Is O1 faster than ON? See about that one. Analysis types. We're doing a worst case analysis. This kind of justifies it, but we also look at average case and even a better analysis type here that is used if the worst case is on rare occasions. So we ran into that. We ran into that actually on the dynamic array when we had to grow the array, right? Increase the array. That was done rarely. We would add maybe, you add 1,000 elements and then you grow it. You add another couple thousand elements, you grow it. So it only happens once in a great while. It's rare. So we have a different kind of analysis for that. And then this upper bound here, just a couple sentences on that, just so we're familiar with it actually, because you just run into the word so you know about it, All right, we'll talk to you soon.